Hi, today we'll talk about the sense of resolved parts or components. In a previous video, I had a problem here with a body, and we have the forces acting on it, the weight acting downwards here. We have the frictional force acting down the slope, the tension in this direction, and the reaction to the block or the body on the slope R. Now, we did not know the sense of each component when we actually wrote the components, and here's a sketch of what I had for R. So R had the components, so R had the components, so we have this F sine 30, F cosine 30, this is 30 degrees, and we have F acting in this direction. So that's the force that we modelled with its components for friction. Now, the specifications of the required components were not precise, and by that, here's an example. We had that we were resolving forces parallel to the plane, and that could be between uphill sense and a downhill sense. And to avoid this ambiguity, whether it's up or down the plane, we need to state the positive sense from the beginning. So here's a table, FORC, and we have our components. So we have, this is our specification here. So parallel to OX, and then we have parallel to OY. So first it's F we modelled. Now you can see F cosine 30 is parallel to OX, but going in the opposite direction, so it's negative. So this will be written as minus F cosine 30 degrees. And parallel to OY, we can see that F sine 30 is parallel to OY, but it's going in the opposite direction, so it's also negative F sine 30 degrees. Next we had, let's just change this. What did we model next? We had R, and we had R cosine 60. This, by the way, is 60, and R sine 60 are acting in this direction. And to add a precise specification for this component, for each component, we have minus R cosine 60 degrees. As you can see, it's parallel to OX going in the opposite direction, and R sine 60 is parallel to OY and in the same direction, so it's positive. R sine 60 degrees. Next we have the tension in the string, and that was modelled, the diagram looking like this. We had, T cosine 60 T sine 60 this being 60 and T acting in this direction. So T sine 60 is, well, let's start with T cosine 60 is parallel to OX and in the same direction, so it's positive. T cosine 60 degrees. And likewise, T sine 60 is parallel to OY and in the same direction, so it's T sine 60 degrees. So here we have R, there's a force T, and lastly we have W. W is acting downwards. And this was the diagram. So it's parallel to OY, but in the opposite direction. So it's minus Y here, W. And no component in the OX plane. So this is 0. And that's it. So what we've done is specified precisely how these components are acting relative to this specification, where OX is the positive direction and OY is the positive direction. Thanks for watching. I'm Alistair.